This is the video for 10.3, and we are talking about operations with radicals. Example number 1, adding and subtracting radicals. For the same reason, we can combine like terms that have the same variable combination. We can combine like radicals that have the same radicand. So for example, 6 times the square root of 11 plus 9 times the square root of 11 is 15 times the square root of 11. 5 times the square root of 3 minus the square root of 12. Now, as this is written, I cannot combine these. However, I can simplify the square root of 12. The square root of 12 is the same thing as saying the square root of 4 times 3. The square root of 4 is 2. So I rewrote the square root of 12 as 2 times the square root of 3. Now I can combine these. And that is my final answer. So pause the video and work out these two on your own problems. Simplify and combine. Here are the answers. I want to call your attention to what I did here with the square root of 28. The square root of 28 is the same thing as the square root of 7 times 4. Now the square root of 4 is 2, but be very careful. Do not skip this step in the process. I have to multiply that with what's already on the outside of the radical. And we talked about this the other day, and so this is going to be my final answer. Because once I simplify this, I can now combine these. Example number 2, multiplying radicals. I'm going to multiply the square root of 10 with this binomial. So what am I going to do? I take the square root of 10 and I'm going to distribute it. I'm going to multiply it with each term inside the parentheses. Now you have to ask yourself, am I finished? Can I go further? You have to look at each term individually and you have to ask yourself, is there anything I can combine? Is there anything I can simplify further? Well, I cannot combine these, and I can't do anything with 3 times the square root of 10. But I can simplify the square root of 60 further. The square root of 60 is the same thing as the square root of 6 times 10. That is 6. And this is 10. I broke it up into its prime factors. I have a pair of 2's. And so now this is my final answer, because now I'm finished. There's nothing I can combine, and there's nothing I can simplify. In the next example, I'm multiplying two binomials together. So what do you do when you are multiplying two binomials together? You have to FOIL. You have to multiply the first terms together, then the outer terms together, inner, and finally the last terms together. So work this out with me and pause the video and make sure that you have the same answer I have after you FOIL. Now I have to ask myself, is there anything I can simplify? Is there anything I can combine? Well, the square root of 36 is 6. And what can I do here? I have 1 times the square root of 18 minus 2 times the square root of 18, which is minus 1 times the square root of 18. Now what happens here? The square root of 9 is 3 times negative 2 is negative 6. Now, again, I have to ask myself, am I finished? Can I go further? 6 minus 6 is 0. I'm left with negative square root of 18. Don't finish too soon. That's the #1 mistake students make in this lesson. They stop too early and then they get the answer wrong. So you have to ask yourself, can I go further? Can I simplify this even further? The square root of 18 is the same thing as saying the square root of 9 times 2. The square root of 9 is 3. Now this is my final answer. Now I'm finished. I cannot go any further than that. Okay, so now go ahead and work out these 2 on your own practice problems. And remember, if you think you're finished, you have to look at each term individually and you have to ask yourself, am I done or can I go further? Is there anything else I can combine? Is there anything else I can simplify? And here's the answers. I want to make sure that you understand where I got 18 and negative 24 from. Well, first of all, these I combined. And I got negative 2 times the square root of 18, which I then simplified down even further. But I want to make sure you understand where I got this from. The square root of 36 is 6 times 3 is 18. The square root of 9 is 3 times negative 8 is negative 24. And finally, I want to talk to you about what a conjugate is. Whenever you have the sum and difference of the same 2 terms, you have conjugates. These are conjugates. They are the sum and the difference of the same 2 terms. Whenever you multiply conjugates together, you get the difference of 2 squares. So a minus b times a plus b is always a squared minus b squared. Now we talked about this in a previous chapter and we talked about why this works. But I am going to rationalize the denominator using conjugates. So remember what rationalizing the denominator means. It means removing any radicals from the denominator. We do not want radicals in the denominator. So we talked about how to do this in the last lesson, but what do I do in a situation like this? Well, I want to multiply the top and the bottom by the conjugate of the bottom. These are conjugates. They are the sum and the difference of the same two terms. And let me show you why I want to do this. The numerator becomes 14 plus 7 times the square root of 3, and look at what happens in the denominator. The denominator becomes 4 minus 3. Now, how did I do that in my head so quickly? Remember what I said. A minus b times a plus b becomes a squared minus b squared. Well, what did I do here? I created a minus b times a plus b. So, a minus b times a plus b is a squared minus b squared. And that is how I knew the denominator was going to be 4 minus 3. Whenever I am multiplying conjugates together, I know the answer is always going to be a squared minus b squared. Now, you don't have to go through this process. I'm just working this out for you so you understand why this works. Because if you know why something works, you'll remember what to do. So now this is 1. And that is going to be my final answer. Okay, let me go over another example for you. I'm going to rationalize the denominator by multiplying the top and bottom by the conjugate of the bottom. So because this is the square root of 7 minus the square root of 2, I want to multiply the top and bottom by the square root of 7 plus the square root of 2. So the top becomes 10 times the square root of 7 plus 10 times the square root of 2 over 7 minus 2. Now again, why is this 7 minus 2? A minus b times a plus b is going to be a squared minus b squared. And again, this is why it works. This is always going to be a squared minus b squared. When you're multiplying conjugates together, it's always going to be a squared minus b squared. And that will remove the radicals from the denominator, which is what we're trying to do. Okay, so now let me show you how this simplifies. And let me actually break this up so you can fully understand how this simplifies. And this is going to be your final answer. Okay, so now go ahead and hit pause and rationalize the denominators using conjugates. And here are the answers. And as always, please email me if you have any questions.